Hey everyone, welcome back to Cracking the GRE Math Subject Test. This is Calculus 2 and we are on question number 7. So in this question we're asked to find the equation of a plane, and we're given some information about this plane. We're told that this line L passes through the plane, that the plane contains L, and that L contains the point A. That means that A is on the plane. The plane contains A, and that the line is parallel to V, so that means that the plane is parallel to V because the line is contained in the plane, and also that the plane contains the point B. So if you draw a picture, let's draw a little coordinate axis here. Let's say we've got some plane here, and so we know that the point A is on the plane, the point B is also on the plane, and the vector V, which is parallel to the line L, that's parallel to the plane as well. So the trick here is to find this other vector, let's call it W, that goes between A and B, that's parallel to the line between A and B, and then to find the cross product between V and W, because that will give us a vector U, which is perpendicular to the plane. And once you have a vector that's perpendicular to the plane, then you can find the equation of the plane. So let's see. V is our vector, -2, 1, 3. W is going to be the vector between A and B. So let's see, that's going to be -2 minus 3 is -5. 3 minus 2 is 1. And 1 minus 1 is 0. And then U is going to be the cross product of V and W. And remember how to find a cross product. You set up a determinant with I, J, and K. And V is going to be here in the second line, -2, 1, 3, and W is going to be here, -5, 1, 0. So we're going to get some number times I minus some other number times J plus some third number times K. So the number that goes in here is going to be the determinant of this 2 by 2 matrix. So that's going to be 0 minus 3, so that's -3. And then the number in here is going to be the determinant of -2 times 0, 0 minus 3 times -5. So that's minus -15 or positive 15. And finally, the third number is going to be the determinant of this 2 by 2 matrix. So -2 minus -5, so that's a positive 3. So our vector U is -3, -15, and positive 3. And actually, we can just simplify. Any scalar multiple of U is also going to be perpendicular to our plane, so we can factor out a 3. Let's call this U prime. And we'll get a -1, or just, let's factor out a -3. So we'll get positive 1, positive 5, and -1. Now, this means that our plane is going to have an equation of the form x plus 5y minus z equals some constant. So we can see that the only answer that has that form is D, but just to make sure that that's actually the right answer, let's check that the constant 12 is actually correct. And we can do that by using one of our points, either A or B, and plugging it into the equation. So if we plug in A, we'll get 3 plus 2 times 5 is 10 minus 1. And yeah, that equals 12. So we know that that's correct. So our answer is D.